most important finding was that there is almost certainly a global ocean. So let's look at the next image. This is a close-up from the Galileo spacecraft, and here you can see this is in the region known as the chaos terrain. There are very few craters, just a few. There are these intriguing cracks and these unusual features that may give evidence for interactions with the global ocean down below. So the three things we need for life, for a habitable environment, now just to emphasize, we're not a life detection mission, we're just looking for the conditions for life, is water, some type of chemicals, specifically organic compounds that can serve as food for any primitive organisms, and then finally, energy. So let's just look at this cutaway model. This is the interior, the upper part of the interior of Europa. And first of all, we have this ice crust. We're not certain how it interacts with this global ocean down below. That's one of the things we're going to go there to find out. We're not sure whether water seeps into the ice crust and forms pockets, whether it comes to the surface. But let's go down here to the interface between the upper rocky mantle and this global ocean. One of the things is to find out what that interaction is. Does it put salt into this ocean? But the most important thing, I think the most intriguing thing, is there has to be a source of energy on Europa in order to provide a habitable environment. There's only about 4% of the solar radiation that comes to Jupiter, that is Europa, from the sun compared to the Earth. But there's another form of energy. Jupiter is huge. It can contain about 1,000 Earths, so it has a lot of gravity. The orbit of Europa around Jupiter, about 3.5 days. When it's close to Jupiter, it's not quite circular. So when it's close, it gets kind of squished in due to this gravity, and then when it's far away, it kind of flexes out. So this flexing in and out produces heat. That's the source of energy that we have. In fact, we see over there on the far side of this cutaway, there are these intriguing thermal vents that not only are hot, but have this heat liberates chemical energy. And this is what we believe is the source of energy on Europa. And they may be similar to thermal vents in the deep oceans of the Earth, where primitive life exists and where life may have originated on the Earth. So that's what we're going to find out from Europa Clipper when we get there. So let's see. Let's look at the final image here, the video of the spacecraft and the instruments. Yes, what are these instruments going to do? What are the instruments? This is the biggest spacecraft ever sent into outer space with the most sophisticated instruments. Starting in the ultraviolet part of the spectrum, our eyes can't see that. We have UVS to study the surface and the atmosphere. Then we have ICE, which is the cameras. There's a wide angle and a narrow angle camera to take impressive pictures, images down to 1 meter resolution. Then we have an infrared spectrometer to look for the fingerprints of the chemicals, especially organic molecules we're looking for. Then a thermal infrared mapper that will look for hot spots and understand the texture of the surface. And then there's also an ice penetrating radar, which is going to study this crust, the upper part of the crust and parts of the ocean. There's also 4 fields and particles experiments. There's a magnetometer, which will study the interior, especially the ocean, try to understand what that is like. There's a plasma detector, which will look at these highly energetic particles around in the environment of Europa. Then there's also a dust detector, and then an instrument, mass specs, which will look for these sophisticated organic molecules that could provide the food for if there are any primitive organisms. So those are the main instruments on board. As I said, they really are the most sophisticated suite of instruments on the largest spacecraft. So there will be 49 flybys of Europa to study the moon from pole to pole. We have pretty much complete coverage, and it will not only realize the main goal of this mission, which is to search for a habitable environment where possibly life could thrive, but it will also address the 3 major objectives of understanding the geology of the surface, the composition and then to characterize the interior. So people ask me quite frequently, well, what is, the thing that most interests you? Every mission we've ever been to, we have always uncovered things that we could not have imagined. That is the thing that really most interests me. There's going to be something there, the unknown, that is going to be so wonderful that we can't conceive of it right now. That's the thing that excites me most. Thank you. Back to Shahre.
All right, thank you, Dr. Barati. We're ready to take your questions now. So for media on the telecom line, press *1 and direct your question to a panelist. If you're on social media, you can use the hashtag #AskNASA, and we may have some questions in the room, so just raise your hand. So we're going to start with the phone lines. So first we've got Eric Berger from Ars Technica. Go ahead.
Hi, thanks very much for doing this. A couple questions. First of all, I think maybe for Jordan Evans, are you targeting the top of the launch window on October 10th, or are there some schedule slips that may push a little bit later into the window? And second, y'all have been very careful to say multiple times that Clipper is not a life detection mission. However, what are some things that you might observe that would be suggestive of potential life in the oceans below? Thanks.
I'll take the first one. So we are absolutely targeting the first day of the launch period, October 10th. It's an instantaneous launch window with each day. As Armando mentioned, the range is set for the 10th through the 12th, but we are on track for the opening of the launch period on October 10th.
Bonnie, you want to try the second?
Yeah, if there is life on Europa in this habitable environment that we're exploring, it will be underneath the ocean, so we wouldn't be able to see it. We're looking for chemicals on the surface, organic chemicals that are the precursors to life. There are, dream things we could observe, like DNA or RNA, but we don't expect to see those. So it really is just looking for a habitable environment and evidence for the ingredients of life, not life itself.
Armando, was there anything else you wanted to add about the opening of the launch period?
No, like Jordan mentioned, we are tracking right on schedule. Our schedule has a margin to the 10th, and I feel pretty confident that unless something unusual comes up, they'll be ready to launch on the beginning of the window.
Okay, great. We're going to take another phone call, and then we'll come to you in the room. Alexandra Whitsey from Nature Magazine. Go ahead.
Yeah, hi. Thanks for taking my call. This is for Bonnie Barati. Could you talk a little bit about kind of the cadence of discovery? So sort of once you're at the Jupiter system and starting to do those flybys, do we sort of expect to get a lot of answers to those big questions you're looking for, those big science questions, on like flyby 1, or is it going to take to flyby 5? Like how quickly will we get those, first glimpse at these big questions we're looking to answer?
Thanks for that question. That's a great question. It's really exciting, and also, I actually did my PhD thesis on the Voyager spacecraft, so I've kind of seen the way this is unfolded, and it's unfolded slowly. Prior to Voyager, we didn't even know that the surface was weird like this. So there's going to be immediate fast things. We'll be able to tell right away, to confirm the discovery of Galileo, whether or not there is a global ocean there. Just by the way the spacecraft goes by, if it sloshes, the spacecraft orbit is going to be different than if it's a totally solid body. So we will know that right away. The second thing that will hit us, is the surface. The cameras on board Europa Clipper are far better than the ones on Galileo. So we'll be able to see these close-ups to see what is the surface like? Are there plume deposits? What do these cracks really look like? So I would say within the first few flybys, we'll just have an onslaught, a deluge of scientific data. And then the stuff that comes later will be more looking at the details of, how deep is the ocean, how thick is the ice crust, what are the interactions between the ocean and the crust. So a big deluge, and then adding on to that, I think will be the cadence.
Okay, we're going to come to the room and go ahead and introduce yourself.
I'm Emily Lakdawala for Sky and Telescope. I have a lot of questions, but I'll confine myself to two. The first one is just a launch day question. If the launch is scrubbed for weather or whatever reason, do you have another launch opportunity that day, or does it need to be recycled to a subsequent day? And the second question is for Bonnie. We know that there are almost certainly the habitable environment ingredients at Europa. So can you be a little more specific about the particular discoveries you expect to make that will help you characterize that habitable environment a little bit more?
Okay, well, maybe we'll start with Armando for that reset question.
So yes, so it's a single opportunity per day. So if we scrub before the launch vehicle is fueled, we have an opportunity the next day to attempt again. If for some reason we fuel the launch vehicle and we scrub, we have to wait 48 hours for the next opportunity.
Okay, the most important thing for determining whether there's a habitable environment and life there, I really think that would be the compounds at the surface. The ocean is still going to be, since it's so far below the surface, it's still going to be somewhat vague, but we can see the surface with the MINE spacecraft, the infrared spectrometer for Europa. We'll be able to see, first of all, the connections between the ocean and the surface. Are we going to see things like evidence for evaporation, evaporate deposits at the surface? What kinds of organic compounds are we going to see? Are there going to be the sophisticated carbon compounds that are the building blocks of life? Will we see, for example, polycyclic aromatic hydrocarbons? I mean, the green thing, which we don't expect, but will we see a simple amino acid? Those are the things that I think would be the big steps forward.
Okay, we're going to go back to the phone lines. We've got Irene Klotz of Aviation Week.
Thanks very much. I have a question for Armando first, which is you mentioned that the launch window was able to be extended about a week or so based on Falcon Heavy performance. Did SpaceX actually do something to enhance performance, or was this based on a reanalysis? And I have a question also for a science question. Thanks.
Armando, why don't you go ahead and answer this one, and we'll come back to you, Irene. Oh, okay. Well, let's take the science question first, actually. Irene, why don't you come back and